Continuing on in section 5.4, here again I have mixed numbers and I'm going to switch them to improper fractions. 5 times 3 plus 3 gives me 18 over 5, and then it's negative there, times 9 times 1 plus 5 gives me 14 over 9, and that's negative as well. Now with fractions we multiply straight across, so it's numerator times numerator over denominator times denominator. I want to try and reduce if I can here. So 18 divided by 9 is 2, and 9 divided by 9 is 1. I can't reduce any further, so I'm going to go ahead and multiply. Negative 2 times negative 14 over 5 times 1. I just rewrote it there in my simplified form. Now I get positive 28 over 5. Two negatives when we multiply make a positive. 28 is bigger than 5, it's greater than 5, so we go ahead and divide to switch it back to a mixed number. 5 goes into 28 5 times, gives me 25 with a remainder of 3. So my answer then is my whole number, 5, and 3, my remainder, over 5, my denominator. So 5 and 3/5. And 8. 8 times 4 plus 1 gives me 33 over 8. I switched from a mixed number to an improper fraction. Same thing here. 3 times 1 plus 2 gives me 5 over 3, and that's negative. Now with fractions again we multiply straight across. So it's numerator times numerator over denominator times denominator. I'm going to reduce if I can. Here 33 and 3 have a common factor, 3. So 33 divided by 3 gives me 11. 3 divided by 3 gives me 1. When I multiply across here now, I have 11 times negative 5 over 8 times 1. So I just rewrote it there in the simplified form. Now I can actually multiply. In my numerator I get negative 55. In my denominator I get 8. Since 55 is greater than 8, I'm going to go ahead and divide. 8 goes into 55 6 times, which is 48. When I subtract, I get 7 as my remainder. So my answer then here is negative 6 and 7 over 8. In example 4, we're going to simplify expressions that are variable expressions. So it works the same way. I'm going to go ahead and multiply straight across. So I'm going to have m times negative 12 over 3 times 5. I have a 12 in my numerator and a 3 in my denominator. They have a common factor of 3. So 3 divided by 3 is 1, and 12 divided by 3 is 4. Now, I can go ahead and multiply straight across. I get negative 4m over 5. In B, same thing here. I'm going to multiply straight across. So I'm going to get n squared times 5n cubed over 10 times 9. If I look here, 5 and 10 have a common factor. 5 divided by 5 is 1. 10 divided by 5 is 2. Now I'm going to multiply across here. It's going to give me n squared times just 1n cubed, which I don't need the 1 if I don't want to, over 2 times 9. Remember, when we multiply powers with the same base, we keep our base and add our exponents. So I get n to the 5th over 18. Or you could have 1 n to the 5th over 18. Either way means the same thing. Here, I'm going to go ahead and multiply straight across. It's just going to give me 3y times y to the 5th over 4 times 9. I'm going to try and reduce if I can. If you look here, my coefficient, my number part of my first term, is a 3. And I have a 9 in the denominator. Those have a common factor of 3. So I can reduce both of them. 3 divided by 3 is 1. 9 divided by 3 is 3. So what I have right now is 1y which is just y times y to the 5th over 4 times 3. Remember that when we are multiplying powers with the same base, we can add our exponents. So in my numerator, I have y to the 6th. In my denominator, I have 12. And 10 here. I'm going to go ahead and multiply straight across, which is going to give me x to the 4th times negative 16x. In my denominator, I have a 6 times 3. If I look here, 16 and 6 have a common factor of 2. So 16 divided by 2 is 8. 6 divided by 2 is 3. So what I have right now is x to the 4th times negative 8x over 3 times 3. I'm multiplying powers with the same base, so 4 and 1 I can add, and that's going to give me x to the 5th. And then I bring my number parts down as well. So my coefficient there is a negative 8 in my numerator. In my denominator, I have 9. So I have negative 8x to the 5th over 9. Remember that my number part there is being multiplied times x. It's its own piece. And in 11. Multiplying fractions, so we multiply straight across. So I have 3z to the 5th times 2z to the 4th over 25 times 15. I'm going to go ahead and reduce here. I have a common factor of 3. 3 goes into 3 one time, and 3 goes into 15 5 times. So what I have right now is 1z to the 5th, or just z to the 5th, times 2z to the 4th over 25 times 5. When I multiply powers with the same base, my z's here, I can add those exponents, which is going to give me z to the 9th power. My number parts are my coefficients. 2 in my numerator, in my denominator, 125. So I get 2z to the z to the 9th over 125. Remember that 2 is times my z, so it's its own piece there. And the last one here is 12. Again, we multiply straight across. So here I have negative 4v squared times 7v cubed over 21 times 16. I have a common factor, a couple of them. 4 goes into 4 once and into 16 4 times. And 7 goes into 7 once and into 21 3 times. So what I really have right now is 1 times v squared, which is just negative v squared, times 1 times v cubed, positive v cubed. I don't need the 1's there. I can if I want to, though. And 3 times 4. We don't need the 1's because 1 times anything is itself. So 1 times a v squared is just v squared. 1 times a v cubed is just v cubed. The v squared is still negative, though. And now we reduce and simplify. Multiplying powers with the same base means we add our exponents, and then we bring down everything else. That's still negative, and 3 times 4 is 12. So I get negative v to the 5th over 12. And that's all I have for section 5.4.